You are watching the Java Spring Boot Overview explanation. Java Spring Boot is an open-source framework built on top of the Spring Framework. It simplifies the development of Java applications by providing a set of conventions and defaults to reduce boilerplate code and configuration. Let's look at the overview of the Java Spring Boot. 1. Spring Framework Basis. Spring Boot builds upon the core principles of the Spring Framework, such as inversion of control, IOC, and dependency injection DI. These principles promote modular, testable, and maintainable code. 2. Convention over configuration. Spring Boot follows the convention over configuration paradigm, which means it provides default configurations for various components. Developers can override these defaults if needed, but in many cases, the defaults work well, reducing the need for extensive configuration. 3. Embedded Web Server. One of the notable features is the embedded web server support. Spring Boot applications can run as standalone jar files with an embedded server, like Tomcat, Jetty, or Undertow. This eliminates the need for external deployment and simplifies the deployment process. 4. Standalone applications. Spring Boot applications are designed to be standalone, meaning they have embedded servers and require minimal external configuration. This makes it easier to develop, test, and deploy applications without relying on external servers or complex setups. 5. Auto-configuration. Spring Boot includes a feature known as auto-configuration, where it automatically configures beans based on the dependencies present in the class path. This reduces the need for manual configuration and enhances the developer experience. 6. Spring Boot Starters. These are pre-configured templates that contain commonly used dependencies and boilerplate code for specific tasks, such as web development, data access, or messaging. Starters simplify project setup and dependency management. 7. Spring Boot Actuator. It provides production-ready features to help monitor and manage applications. This includes health checks, metrics, application information, and more. Actuator endpoints can be exposed for monitoring purposes. 8. Microservices support. Spring Boot is well suited for building microservices due to its modularity, ease of deployment, and support for creating RESTful APIs. It integrates seamlessly with Spring Cloud for building distributed systems. 9. Spring Boot CLI. The command line interface, CLI, allows developers to scaffold, test, and run Spring Boot applications from the command line. It's a convenient tool for quick prototyping and development. In summary, Java Spring Boot streamlines the development of Java applications by providing defaults, conventions, and a set of tools to simplify common tasks. It's widely used for building a variety of applications, from monoliths to microservices, thanks to its flexibility and extensive ecosystem. Let's look at the key components and architectural concepts. The architecture of a Java Spring Boot application is based on the principles of the Spring Framework, with Spring Boot providing additional conventions and tools to simplify the development process. Here's an explanation of the key components and architectural concepts in a typical Java Spring Boot application. Spring Boot Starter. Spring Boot Starters are a set of convenient dependency descriptors that you can include in your application. They simplify the process of adding dependencies by providing pre-configured setups for common use cases. For example, the Spring Boot Starter Web includes dependencies and configurations for building web applications. Application Class. The main class of a Spring Boot application is annotated with that Spring Boot application. This annotation is a combination of at configuration, at enable auto configuration, and at component scan, providing the core configuration and enabling Spring Boot's auto configuration features. Embedded Web Server. Spring Boot includes an embedded web server, for example, Tomcat, Jetty, or Undertow, that allows your application to run as a standalone executable jar file. This eliminates the need for external server configurations. Auto-configuration. Spring Boot's auto-configuration automatically configures your application based on its dependencies. For example, if you include the Spring Data JPA starter, Spring Boot configures a data source, entity manager factory, and transaction manager without requiring explicit configurations. Spring MVC. Spring Boot applications often use Spring MVC, Model View Controller, for building web applications. Controllers handle HTTP requests, services contain business logic, and views, templates, generate the HTML or other responses. Spring Data. Spring Boot simplifies data access using Spring Data. It provides a consistent and convenient way to interact with databases. Spring Data JPA, for example, allows you to work with Java Persistence API, JPA, entities and repositories, Timeleaf or other view templates. For web applications, Spring Boot supports various view templates. Timeleaf is a commonly used templating engine that integrates well with Spring Boot. Other options include FreeMarker, Velocity, or even front-end frameworks like React or Angular. Spring Boot Actuator. Spring Boot Actuator provides production-ready features to help you monitor and manage your application. It includes built-in endpoints for health checks, /actuator/health, metrics, /actuator/metrics, and more. Externalized configuration. Spring Boot allows you to externalize configuration properties, reducing the need for hard-coding values in your code. Configuration can be specified in property files, for example, application.properties or application.yml, or through environment variables. Profiles. Profiles in Spring Boot allow you to define sets of configurations for different environments or scenarios. Profiles can be activated based on the environment or other conditions, providing flexibility for development, testing, and production. Spring Boot DevTools. DevTools provide features like automatic application restart, live reloading of changes, and enhanced development experience. These tools help developers iterate quickly during development. Security. Spring Boot includes security features that make it easier to secure your application. You can configure authentication and authorization using Spring Security. Logging. Spring Boot uses a flexible and comprehensive logging system. By default, it uses the SLF4J API with Logback as the implementation. Logging configurations can be customized to meet specific requirements. Testing support. Spring Boot provides testing support with annotations like its Spring Boot test, which allows you to write integration tests that load the entire application context. Packaging and deployment. Spring Boot applications are often packaged as standalone executable jar files. These jar files include an embedded web server, making deployment as simple as running the jar. Alternatively, applications can be packaged as WAR files for deployment in traditional servlet containers. This architecture provides a robust foundation for building scalable, maintainable, and production-ready Java applications with minimal boilerplate code. The use of conventions, starters, and auto-configuration features in Spring Boot streamlines the development process, allowing developers to focus on business logic rather than infrastructure concerns. Let's create a simple Java Spring Boot project for a basic task management system. This example will use Spring Boot, Spring Data JPA for database interaction, and an H2 in-memory database for simplicity. The project will have a RESTful API to perform CRUD operations on tasks. Step 1. Project Setup. Create a new Spring Boot project using your preferred build tool, for example, Maven or Gradle. You can use Spring Initializer, https://start.spring.io, or set up the project in your IDE. Step 2. Project Structure. Your project structure might look like this. Step 3. Model Class, task.java. This represents the entity to be persisted in the database. Step 4. Repository Interface, task repository.java. The repository interface extends JPA repository to perform CRUD operations on the task entity. This handles database operations for the task entity. Step 5. Service Class, taskservice.java. The service class provides methods to interact with the repository and perform business logic. Step 6. Controller Class, taskcontroller.java. The controller exposes RESTful endpoints for performing CRUD operations on tasks. Step 7. Application Properties, application.properties. This configuration sets up an H2 in-memory database and enables the H2 console for debugging. Step 8. Main Application Class, taskmanagementapplication.java. This class contains the main method to start the Spring Boot application. This is the entry point to the Spring Boot application. To run the application, execute the main method in the Task Management Application class. You can then access the API at http localhost 8080/API/tasks. Use tools like Postman or curl to test the CRUD operations. Additionally, you can explore the H2 console at http localhost 8080/H2 console for database inspection. This example provides a foundation for building more complex Spring Boot applications with additional features, security, and front-end integration. Hope you have learned something and feel confident about Java Spring Boot. Please check out our channel for more concepts and interview questions. Like, share, and subscribe our channel for updates and notifications. Good luck for your upcoming interviews.